Hello, everyone, and welcome. Thank you for making the time and especially for bringing the people we asked for: product management, people who know the users, and the owners of the systems this product will have to live with. That mix is not a courtesy. It is the working material of the phase we are starting today. This session kicks off the product requirements analysis. Over the next 40 minutes or so, I want to do three things. First, show you where this phase sits in the road towards a developed product and what it delivers. Second, walk you through how we will actually work together. And third, and this is the part I care about most, explain something that surprises many customers. Not everything you have written down as a need will become a requirement, and that is not a loss. I will show you with three concrete examples what happens to those statements instead, and why your intent is better protected that way. One image before we start, because it anchors everything that follows. In the middle, you see the product sitting inside its own system boundary, the dashed circle. Everything we will write as a requirement is a promise about behavior at that boundary. What crosses it? What is observable at it? Notice that the product itself sits inside a larger dashed box, the larger system. Your product may well be a subsystem of something bigger, and then it has neighbors, peer subsystems it must interface with. Users and external systems connect from outside. And at the bottom, deliberately drawn with no line to the product at all, are the stakeholders. Parties with a real interest in this product who never touch any interface. Keep that little band in mind. It returns near the end of the deck with some force. So, from your needs to a verifiable, solution-neutral product specification, and why not every need should become a requirement? Let us begin with why this phase exists at all. Everything starts from your input. Some customers hand us a formal requirement specification of 100 pages. Others bring a concept sketch and a head full of intent. Both are valuable, and I want to say clearly at the outset, nothing on this slide is criticism. These four risks are simply the natural state of early input, at every maturity level we have ever seen. The phase exists to convert that input safely, not to grade it. Risk 1. The what and how arrive entangled. Look at the little example on the card. Use an STM32 to control the valve. The real need there is valve control. The microcontroller is a design choice, and making it this early quietly closes doors before anyone has explored whether better options exist. We will spend a whole slide later on how we untangle this without losing either part. Risk 2. No way to verify. The system shall be easy to use. How would anyone test that, and with which equipment? This risk cuts deeper than it looks. It is not only that the test rigs and fixtures surface late as unplanned cost. It is that without acceptance criteria, it is never clear whether a requirement is met at all, and therefore never clear whether a design is good enough. A project can drift for months in that ambiguity. Risk 3, my favorite: hidden assumptions. Our operators always wear gloves. Perfectly obvious to you, written nowhere, and it quietly rules out a capacitive touchscreen. Remember this example because in a few slides a touchscreen will appear on the legitimate side of a line, and this sentence is exactly the kind of unwritten fact that can invalidate it. Surfacing knowledge like this is what the interviews and scenario walkthroughs later in the phase are designed for. And risk 4, unreliable estimates. It must support multiple markets. 2 certification regions or 10. The difference is months of effort. Ambiguity like that forces anyone quoting the work into a bad choice. Pad the contingency and make the offer unattractive, or underestimate and disappoint everyone later. The point of the bar at the bottom is the economic argument for this whole phase. The clarification effort must be spent at some point. Spending it now, before commitments harden, is simply the cheapest moment to spend it. Here is the road ahead so you can place today in context. Pre-development runs in 4 phases, each producing a deliverable that stands on its own. Phase 1, where we are now, is the product requirements analysis. It produces the product requirement specification, the PRS, what the product must do and how it must behave, seen from the user and stakeholder perspective. Phase 2, the system requirements analysis, is the technical translation. Architecture, concept trade-offs, prototypes, feasibility and risk, captured in the SRS. Phase 3, the industrialization analysis, applies when the product goes to volume production, and also when it must be manufactured with a specified guaranteed quality. It covers manufacturability, quality targets, manufacturing partners, and the supply chain. And Phase 4 turns all of it into a development plan. Milestones, decision gates, resources, and an estimate you can defend in front of your own management. Notice the arrows between the phases because they carry an important message. The teal arrows pointing forward are labeled input. Each phase's deliverable feeds the next. But the gray arrows pointing back are just as real. This process is iterative by design. Phase 2 will discover that some requirement is expensive or infeasible, and that finding flows back and updates the PRS through a controlled change. Later phases update earlier baselines the same way. So when in a few weeks an engineer comes back and says a requirement needs adjusting, that is not the process failing. That is the process working. Now look at the who is involved block in each card, because your own role changes deliberately as we move right. In Phase 1, you are a continuous source. We need product management as the named validation authority, end users or people who can genuinely speak for them, and the owners of any interfacing subsystems whose interfaces are not yet settled. On our side, the system engineering team leads the phase and owns the PRS. In Phase 2, your involvement becomes punctuated decision authority, a named person who can decide on changes at defined review points, interface owners, and end users again when prototypes need validating. Our side grows with engineering domain specialists, and component suppliers may be consulted informally. In Phase 3, you become the agreement counterpart per production topic, quality, volumes, service, logistics, while the manufacturing partner is selected and staged in. And in Phase 4, you are the signatory, release, budget, and signing authorities, because the people who discussed requirements with us are usually not the people who can sign a development plan. Underneath all 4 phases runs one rule, and it is worth memorizing. Every actor, every interface, every agreement topic, and every decision has someone or an authoritative document that can speak for it. Knowledge and decision authority never silently confused. You will see that rule at work throughout today. Everything in this phase converges on one document, so let me tell you exactly what it is through 3 properties. First, it is the contractual baseline. The PRS is the agreement on what the product must do, the reference against which every design will be evaluated and every verification will be planned. When someone asks a year from now, was this promised? This is the document that answers. Second, it is solution neutral. The PRS defines behavior and qualities, never internal implementation. That is deliberate discipline, not vagueness. Every internal design decision written into a requirements document is a door closed on the engineers before they have even looked at the problem. We keep those doors open on purpose, and the next slides define precisely where the line runs. Third, and this one takes some getting used to, it is feasibility unconstrained. The PRS states what is needed. Whether each requirement is achievable and at what cost is evaluated in Phase 2 and fed back. So you will not find a single if possible or subject to feasibility in this document. That is not overconfidence. It is division of labor. The needs are stated cleanly here. The confrontation with physics and budget happens in the next phase, often through an early bill of materials, and the loop you saw on the roadmap carries the consequences back. That loop may run several times by design. On the right, you see the table of contents we will fill together, the business case background, the system identification with its context diagram, use cases, the system state model, scenarios in 3 flavors, functional and non-functional requirements, prioritization, acceptance criteria, and finally the consolidated traceable listing. And note the word together. This document is written with you in workshops, interviews, scenario walkthroughs, and with early mock-ups where they help. How do we get there? In 10 structured steps. I will go through them quickly because several get their own slide later. We begin by capturing the business context, the market problem, the positioning, the commercial assumptions. You will see later why this chapter earns its keep. Step 2 identifies the system, the boundary, the actors, the interfaces, and artifacts, all condensed into one context diagram, essentially a worked-out version of the picture on the title slide. Step 3 defines the use cases, and we are systematic about coverage. Every actor goal, every life cycle phase, every mode and trigger accounted for. Step 4 models the system states, the product's modes of operation, and the transitions between them. This sounds abstract, but it is where behavior during startup, faults, and maintenance stops being assumed and starts being specified. Step 5 is where the phase gets its texture. We write scenarios, concrete walks through each use case, and not only the sunny day version. Normal flow, alternative flows, and failure flows written with the same care. Then step 6, highlighted in amber for a reason. We extract the functional requirements from those scenarios. Extract is the operative word. Requirements are not invented at a desk. Every system responsibility that appears in an agreed scenario becomes a shall statement. That is what makes traceability automatic rather than an afterthought. Step 7 captures the non-functional requirements, things like performance, compliance, environmental conditions, and more, each with its rationale attached. Step 8 prioritizes on 5 levels from essential, which effectively defines the minimum viable product, down to future. Step 9 asks, for every single requirement, the question that keeps us honest: how will we test that? And finally, Step 10 compiles everything into one consolidated traceable listing. One elegant economy to notice. The scenarios do double duty. The flows we agree with you are already high-level acceptance criteria for the requirements extracted from them. The document verifies itself, in a sense, from the way it is built. I promised precision about solution neutrality, and here is the line. It is not no technology in the PRS. That would be both impossible and wrong. The question is which technical choices belong there. On the left, choices that belong: the system shall support Wi-Fi connectivity. The system shall provide a capacitive touchscreen interface. The system shall support Bluetooth audio streaming. These are product-level choices. They are visible to your users or driven by the market and the ecosystem the product must live in. They describe a capability the product offers to the world, so they are genuine requirements, even though they name a technology. On the right, choices that wait for Phase 2. Use an STM32 microcontroller. Store the data in flash memory. The firmware shall use a state machine. Only the engineers building the product care about these. Stating them this early does damage in a subtle way. It hides the real need behind a technology, so nobody can later tell what problem the STM32 was solving. The rule of thumb on the dark bar is the one to remember. If you or your users can see it, interact with it, or would care about the choice, it is a product requirement. If only the engineering team cares, it belongs to a later phase. And a small callback. The capacitive touchscreen sits on the legitimate side of this line, and yet 2 slides ago a single unwritten sentence about gloves could kill it. Both slides are true at once. A choice can be at the right level and still be wrong on the facts, which is exactly why we dig for those facts. One more thing, because it comes up in almost every project, sometimes you will insist on an internal choice, for platform reasons, for service reasons, for history. That is your right. What we do then is extract the underlying functional need as the requirement, and record your choice as an explicit constraint with its rationale attached, never disguised as a requirement. 10 years from now, whoever maintains this product will know both what was needed and what was chosen, and why. So how does the actual work look? On the left, the methods. Stakeholder interviews with product managers, end users, and domain experts. Open questions because the most valuable answers are to questions we did not know to ask. Workshops and whiteboarding sessions where clarification and prioritization happen live, with everyone in the room. Scenario walkthroughs, narratives of real-world use, including the edge cases, which are unreasonably good at exposing missing interactions. Early mock-ups and prototypes, because people correct a model in front of them far more readily than they correct a paragraph. And surveys, where a product has many end users and we want quantified priorities rather than the loudest voice. Now the panel on the right, the triage round, which is a specific promise about how we treat your time. There is a category of facts that only you can supply. Target volumes, product lifetime, certification regions, choices that are genuinely yours to make. Rather than burying those as dozens of little flags inside a draft document and making you dig them out, we collect them up front, as one focused list, before drafting starts. For each item, you have 3 options, and all 3 are legitimate. Answer it, and the value flows straight into the document, no flag. Skip it for now, and we proceed with our best inference, visibly marked so it cannot silently become the truth. Or say skip the rest, and we draft on judgment and flag only the true gaps. The triage is never a gate. A draft always follows, whatever you do with the list. And a promise that connects to the next slide. We will never ask you to sign off values that engineering or published knowledge actually owns. Which raises the obvious question, who owns what? That is exactly the next slide. A specification in progress inevitably contains values not yet pinned down. Most processes handle this with a blizzard of TBD markers. We handle it with one question, asked before anything gets flagged, who owns this value? There are exactly 3 possible answers and each leads somewhere different. First, you, the stakeholders, target volumes, service life, certification regions, behavioral choices that are genuinely business decisions. Those we asked directly and early, that was the triage round. Where a stated value still awaits your confirmation, it is marked TBC. Where it is genuinely missing, TBD. And both are resolved before the document is baselined, so the baseline is clean. Second, published knowledge, standards, and established science. If human perception research says feedback within roughly 100 milliseconds reads as instantaneous, we write that firmly with a citation, and we never flag it. Reviewers check the source if they doubt it. What we will not do is ask you to confirm a number you do not own. That would be theater, and worse, it would put the decision with the party least equipped to make it. Third, engineering, meaning phase 2. Power budgets, internal timing, concrete mounting specifics, the performance figures that fall out of a design rather than precede it. In the PRS, these appear as functional needs. The concrete figure is a design output of the system requirements analysis, not a pending item cluttering this document. And the bar at the bottom restates the deliberate omission I mentioned earlier. Feasibility is out of scope here, on purpose. No requirement in the PRS carries an achievability caveat. Phase 2 evaluates feasibility and cost, often via an initial bill of materials, and feeds adjustments back. The gray feedback arrows from the roadmap in action. We now arrive at the heart of this presentation. Everything so far was process. This is philosophy, and it is the part that prevents the most misunderstandings later. The statement on the title is meant literally. Not everything you write becomes a requirement, and that is by design, not by neglect. Your input naturally lives at different heights, and the ladder on the left names them. At the top, organizational drivers, the reasons your company builds this product at all. Below that, user goals, what a persona wants from life with the product. Then propositions or themes, the value families that individual needs cluster into. And only at the 4th rung, user needs, statements anchored to a moment and an interaction, in the form, when I am in this situation, I want this interaction so I can get this benefit. Below the ladder, in amber, the requirements. When this triggers, the system shall do that, verifiable at the product boundary. Here's the key. Only user needs translate directly into requirements, because only they are anchored to a moment and an interaction you can test. Everything above them is a driver. Drivers are not second-class content. They motivate and group the needs. But precisely because a driver stands behind many needs at once, it cannot be filed once as a requirement. It decomposes across the specification instead. And notice, by the way, how close user goal and user need sound. That closeness is not an accident of our vocabulary. It is exactly why goals slip through reviews disguised as needs, and one of our examples will show it happening. There are 2 classic mistakes with drivers, and both destroy value. Promote a driver as is and you get a requirement nobody can verify. Discard it, and you break the traceability to why the requirements underneath it exist. We do neither. The next 3 examples show you what we do instead, and I have chosen them because each one appears in some form in nearly every intake document we have ever received, very possibly including yours. That is not a criticism, it is the reason these 3 slides exist. Users must receive clear, simple performance insight that indicates when things are okay or need attention. Take a moment with this sentence. It has the word must, so it looks like a requirement. It talks about users and what they get, so it reads like a need. It is neither, and the same shape recurs across reliability, maintainability, serviceability, sustainability, and even commercial strategy. Four tells give it away. 1. The subject is generic. Users, not a specific actor in a specific moment. A real user need sounds like, when I am performing daily maintenance, I want. 2. There is no situation. No when at all, and a trigger that never switches off is not a trigger. It is a permanent aspiration. 3. Value language. Clear, simple insight. Describe the worth of a capability, not an observable interaction. Nothing here can be watched happening at the product boundary. And 4. The structural proof. Fan out. Scan the rest of the same intake document, and you will find several concrete user needs sharing this sentence as their banner. It is a parent, not a sibling. It sits a rung too high on the ladder. So the diagnosis: this is a driver, a proposition-level value statement. And now the two tempting responses, both wrong. Promote it as is into the requirements chapter, and you own an unverifiable shall that will haunt every design review. Strike it out, and the intent it carries, which is genuine and valuable, evaporates. We do neither. We decompose it, and the next slide shows exactly where each part lands. One statement, 4 destinations. Watch how nothing is lost. The value intent, the actual point of the sentence, lands in the product objective and context. Operators can identify the need for attention without interpreting raw technical data, stated once prominently as the value the product offers. That is the sentence's soul, preserved at the level where it belongs. The capability inside it becomes a real functional requirement. When the performance state changes between nominal and attention needed, the system shall present the updated status through the operator interface. Notice what happened. Suddenly there is a trigger, a subject that is the system, and an observable behavior. This one can be tested. The quality words clear and simple become a non-functional requirement with numbers in it. Status presented as one of at most so many defined states, available within so many seconds of detection. We will come back to how adjectives become numbers. It deserves its own slide. And the grouping effect improves the document structure itself. Intake rows that shared this driver as their banner are usually one capability seen from several situations, prime candidates to merge into a single shared use case instead of 5 overlapping ones. The driver even helps us deduplicate. Then traceability runs back upward. Every derived requirement names this driver as its origin. So the question, why does this requirement exist, always has an answer, and so does the harder question that comes up in every cost discussion. What happens to the value if we cut it? 2 repairs made that decomposition work, and they are general tools you will see us apply again and again. The first is the product boundary, the dash circle from the title slide, now doing real work. Users must receive insight asserts an outcome inside the user's head. That is on the far side of the product boundary. The product cannot perform it, cannot observe it, and can never be verified against it. No test in the world confirms that insight was received. The repair is to separate 3 layers, and the discipline is in keeping all 3. Layer 1 product behavior becomes the requirement. The system presents performance feedback distinguishing a nominal condition from an attention-needed condition. Verifiable at the boundary. Layer 2 design intent is recorded as context. This feedback is designed to be usable by the operator as a basis for deciding whether action is needed. We write that down, honestly, as intent. It guides the designers without pretending to be testable. Layer 3, the user's response, whether they actually gain insight, feel reassured, act on it, is theirs. It is never a requirement because the product does not direct it. The test on the dark bar is the one to take home, and it works on every statement in any document. Does the product do this, or does the actor? Verbs like receive, understand, trust, have peace of mind, and for machine actors, verbs like reset or take action sit on the actor's side of the boundary. Whenever we meet one, we rewrite it as what the product emits, presents, transmits, or records. Same intent, testable promise. The second repair deals with the adjectives. Clear, simple, fast, reliable, user-friendly. These are genuine quality intents, and Every one of them is unverifiable exactly as written. Each either gets concrete acceptance criteria or gets flagged to whoever owns its definition. Two examples, before and after. The system shall be easy to use. What does easy mean, and how would anyone test it? After repair, a first-time user shall be able to perform a specific key task within 5 minutes without referring to a manual. Now it is measurable by observation or a small usability study. The device shall not overheat. No conditions, no pass or fail. After repair, the device shall operate within specifications at ambient temperatures up to 50 degrees for at least 24 hours. Clear conditions, unambiguous verdict. The bar at the bottom is deliberately blunt, and it applies to us as much as to you. A quality word that survives into a baselined requirement without a measurement attached is a defect, not a requirement. If the right threshold is genuinely yours to choose, we will not invent it. We flag it to you visibly through the mechanisms you have already seen. What we will not do is let an adjective smuggle an open question past the baseline. Second example. When I am a user, I want to reduce labor, so I have more free time to spend on other tasks or my private social life. Now, before anyone smiles, this is one of the most valuable sentences an intake document can contain, and I will get to why. But look at its form first. Syntactically, it is a flawless need. When I want, so I can. Every box ticked, which is exactly why sentences like this slip through review after review. Templates guard against smuggled solutions. They do not guard against the wrong abstraction level. Three tells. First, the when states an identity, not a situation. When I am a user is true all day, every day. Second, the want names an aggregate outcome. No single behavior delivers reduced labor. And here's a test you can apply yourselves. Could many unrelated capabilities all satisfy it? Then it is a goal, not a need. Third, the benefit lies outside any product boundary. And note the precision here. The product can reduce the labor it itself demands. It cannot deliver free time, and it certainly cannot deliver a social life. Whether saved minutes become leisure is the user's life, not the product's behavior. So it is a user goal, one rung up the ladder, and remember how close those two names sound. Where does its value land? Three places. It shapes the value proposition and the main product objective. This product reduces the operator labor the system itself requires. It yields a measurable derivative once anchored. Routine daily tasks shall not exceed so many minutes per day, or a defined fraction of your current product. And it becomes a prioritization lens. When we rank requirements later, capabilities that reduce demanded labor score higher because this goal told us they should. A goal is not a need, but a well-stated goal steers the whole document. Third example, and now the manufacturer speaks. When I am the manufacturer, I want the consumables revenue per customer to grow or stay break-even, so I can safeguard the continuity of the company and its investments in service and portfolio. Let me say immediately, this is legitimate, valuable input. The manufacturer is a real stakeholder, and a product that ignores its own business model serves nobody. And yet this is neither a user need nor a product requirement for three reasons. First, the supposed actor never crosses the system boundary. The organization does not operate the product. It appears at no interface. Its service technicians may well be actors. The company itself is a stakeholder without being one. Remember the little band on the title slide, drawn with no line to the product? This is that band speaking. Second, the want is a market outcome. Revenue depends on pricing, portfolio strategy, competition, and your customers' purchasing decisions, all of it outside the product boundary. No product behavior can deliver or verify it. Third, only the business itself can validate this statement. No operational user can confirm or reject it. Sign-off belongs to product management and commercial leadership. The rule from the roadmap again. Every concern has an owner who can actually speak for it. So where does it go? Into the business case background, recorded as commercial rationale and positioning, attributed to its stakeholder. That chapter I mentioned at step 1 is precisely the home for statements like this. What we will never write is the system shall grow revenue, a market outcome dressed up as product behavior, unverifiable by construction. But recording the goal upstream is not the end of the story because organizational drivers usually cast what we call a shadow, a residue that is verifiable at the product boundary and that legitimately does flow down into requirements. The table shows the pattern with 4 drivers of the same family. Recurring consumables revenue. The goal stays in the business case, but its shadow is testable. Where parts and consumables shall be compatible with the manufacturer's consumables portfolio. A compatibility constraint any test bench can check. Platform strategy and reuse. The product shall be mechanically and electrically compatible with platforms X and Y. An interface constraint. Protection of intellectual property. Critical differentiating functions shall not depend on components carrying exclusive supplier IP. A sourcing constraint, verifiable by inspection of the design. And then the 4th row in red, because it teaches the opposite lesson, sales attractiveness. Usually nothing flows down at all. Demo material and value stories are not product properties. When a driver casts no shadow, we do not force one. We route the concern to the organization that owns it, in this case, sales, and we record that routing so the intake row is still accounted for. The pattern is constant, and it is the bar at the bottom. The goal stays in the business case as rationale. Only a constraint verifiable at the product boundary reaches the requirements, and it is named after the driver it serves. Note the word serves. The constraint serves the goal, it never guarantees it. Compatible wear parts do not guarantee revenue. Being honest about that difference is what keeps the requirements clean and the business case truthful. And now the payoff of all this classification, the slide that justifies the effort. Because once drivers are separated from user needs, something becomes visible that was invisible before. Look at the 2 blocks. The manufacturer wants consumables revenue per customer to grow or hold. The customer wants consumables cost reduced plus supplier independence. Replaceable, dual-sourced parts, no lock-in. Both entries are legitimate. They often arrive in the very same intake document, pages apart, each perfectly reasonable in isolation. Neither is a defect, and they pull the product in exactly opposite directions. While both hide among hundreds of intake rows at different abstraction levels, this tension is invisible. Classify them, and it stands in the open. So here is what happens next, and just as importantly, what does not. The conflict is surfaced explicitly in the business case background, as an open positioning decision with its owning stakeholder named. It is resolved at business level as a deliberate positioning choice by you, and the resolution then becomes the rationale for whichever constraints survive into the requirements, so the trade-off stays visible for the product's whole life. What must never happen is on the dark bar, a requirement that quietly favors one side. That hides a strategic decision inside an engineering artifact, which is the worst possible place for it, because that is where it is discovered late by the wrong people and disputed. Surfacing a conflict early is not a problem with the process. It is one of the main services the process performs. We have talked a lot about what we will do with your input. This slide turns the tables. Here is the quality bar you can hold us to on both sides of the document. Every requirement in the PRS will be atomic, one behavior, one statement, one verdict. Triggered. When this condition, the system shall this behavior. Never behavior floating in a vacuum. Verifiable acceptance criteria alongside every statement, whether by test, measurement, inspection, or analysis. Solution neutral, per the line we drew on slide 6. Prioritized on 5 levels from essential down to future, and checked for dependency consistency, so an essential requirement never secretly depends on a future one. And covering failure, not just success, the failure scenarios written with the same care as the sunny day. And on the dark side of the slide, the promise that answers the worry this whole middle section may have raised. Nothing you gave us gets lost. Every single intake row is accounted for as a requirement, a named driver, a constraint, a flagged question, or a recorded routing to the right owner. Those are the 5 possible fates, and every row gets exactly one of them, auditable. Requirements trace upward to a small set of named drivers, your themes, your goals, your business interests. So 2 questions always have answers. Why does this requirement exist, and what happens to the product's value if we cut it? The result reads as a contract in both directions. You can verify every promise we write, and we can defend every constraint we carry. Now to the practical heart of the collaboration, people. Everything in this phase runs on two distinct contributions from your side, and we establish at kickoff, ideally today, who provides each. Contribution 1, Validation Authority. Someone who confirms requirements, decides the customer authority values from the triage list, volumes, service life, certification regions, cost positioning, and can say yes on your behalf. Typically, that is product management. This person is named, and the phase exit criteria literally depend on their sign-off. Contribution 2, Behavioral Knowledge. The people who know how each actor actually behaves and what it needs. And this one follows mechanically from the actor list. For every actor in the context diagram, either a knowledgeable human joins the elicitation or an authoritative document exists. The table maps this per actor type. End users who can speak for themselves, they do in interviews and workshops, with product management validating. Users who cannot, incapacitated or nonverbal. A care domain expert speaks for them, a clinician or caregiver, with certification and regulation expertise joining the validation. Animal actors, and yes, they occur. The handler who knows real behavior, the farmer, not the brochure, with a welfare or compliance authority validating. External systems whose interface is settled. No human needed at all. The interface specification itself is the authority, and values resolved by citation, with the document owner consulted only on ambiguity. And then the highlighted RAW, the one that connects back to the larger system picture on the title slide. Subsystems whose interface is not settled. There, the subsystem owner participates in person as a negotiating party, because this analysis will shape that interface, not merely record it. If that owner is a third party, we identify them as early as possible because third parties need lead time. Two rules govern all of this on the bar at the bottom. The two contributions must never be silently conflated. A product manager may validate on behalf of end users, but cannot substitute for a caregiver's knowledge, nor speak for an interface that is not actually settled. The same person may hold both roles for a given actor, but we always know which hat is on. And your actor list doubles as the invite list. Every actor ends the phase with a named person or an authoritative document behind it, verified at completion. An auditable roster, not an assumption. So, in summary, 4 asks. First, people in the room, product management as the named validation authority, end users or their behavioral representatives, and the owners of interfacing subsystems where interfaces are not yet settled, available for the workshops, interviews, and walkthroughs. Second, direct answers in the triage round. The facts only you own, answered early against one focused list. An hour spent there saves days later. Third, a named owner per concern, validation authority for each stakeholder interest, explicitly including the business drivers and any conflicts we surface between them, because as you saw, those conflicts need a decision maker, not a diplomat. And fourth, perhaps the most important, openness when we reclassify. When we tell you a need is actually a driver, that statement is being preserved and traced to, not rejected. Challenge us on every classification. That dialogue is the method, not an interruption of it. Where this ends, a baselined product requirement specification, which is solution neutral, verifiable, traceable to your goals, followed by your go decision toward phase 2, the system requirements analysis. Let me close with a sentence from Voltaire. Perfect is the enemy of good. I want to be honest with you about what this phase can and cannot do. It does not chase a perfect specification. Perfection is not attainable. No amount of analysis catches everything, and new insights will still surface later, in prototyping, in testing, sometimes on the production line. That is precisely why the process has those gray feedback arrows built into it. They exist because we know things will pop up, and they give every surprise a controlled way home. But, and this is the point of doing it at all, reaching good already delivers most of the value. A shared understanding of the product, so we are all building the same thing. Promises that can be tested, so good enough has a definition. Conflicts surfaced while they are still cheap to resolve, and estimates that can be trusted because they rest on statements everyone has seen and agreed. That is what good looks like, and good is what we will deliver. Thank you for your attention and for the work we are about to do together.